Hello and welcome to this webinar where I will talk more about Planet's solution for precision agriculture. My name is Dr. Eric Tillman and I'm working as a technical sales engineer and Earth observation specialist for agriculture at Planet. When it comes to monitoring of crop health and managing fields, high temporally frequent information across the season is crucial to potentially detect any growth anomalies timely and to plan any action in relatively narrow time windows in order to ensure optimal outcomes. If farmers or advisors missing information in key moments, they are acting on an incomplete picture. Farmers need enough in-field detail to get their job done. You require a source of data that provides enough spatial detail to show variability within the field, as well as match equipment to apply the correct management strategies. Another aspect in this context is data consistency. Temporal and spatial consistency is very important to derive analytic results you can rely on. Within agriculture, that means it's vital that what's being measured in time series of data is related to real changes happening in the field and not to shifts between different sensors. And last, the solution needs to be cost-effective with a return on investment to make the technology and platform a worthwhile endeavor. Of course, this can be viewed from various angles, such as increased yield, decreased inputs, and overall sustainability. Or it can relate to the cost of working with the data itself, building out infrastructure and workflows to produce a data pipeline that returns consistently valuable insights. The question is, can satellite imagery provide all this? What we have seen so far is that until recently, the digital transformation of agriculture has been prevented, among other things, mainly by the lack of reliable and adequate satellite imagery. Image collection was often too infrequent, the spatial resolution of the imagery too coarse, and the geographical coverage of suitable data limited in order to build reliable services on top of it. And moreover, often the business models and the data access provided by the imagery providers was too complicated and expensive. Even public data sets aren't without costs. Implementing storage and processing requires significant amounts of both capital and time. We at Planet think there's a better way of serving the agricultural business with the right data to accelerate its transformation. Our mission is to image the whole world every day, making change visible, accessible, and actionable. These are the main components and features of Planet's monitoring solution. Our always-on satellite constellation collects imagery over the entire landmass of the globe on an almost daily basis. You do not need to place any tasking orders, then wait days for delivery. This saves you time and effort, and the imagery is available when you need it. Almost daily monitoring at 3-meter resolution ensures an up-to-date field-level overview of your operations, and near real-time information allows you to detect and respond to changes in crops as they occur. All data collected is published in Planet's cloud-based platform and can be easily accessed via our online GUI or through our APIs. Here's Planet Satellite, the so-called DARF. It's about the size of a shoebox, 10 by 10 by 30 centimeters and just 4 kilograms. We build all our satellites in-house and we are constantly innovating and incorporating the latest technology into the small satellites. They are all capable of capturing spectral reflectance in the visual and near-infrared part of the electromagnetic spectrum at 3-meter spatial resolution. Our most recent version of the sensor provides an additional red edge band, which is especially beneficial for detecting vitality change in vegetation. Additionally, we have a constellation of 21 SkySat satellites, which are capable of multi-spectral imaging at 65 centimeter ground sampling distance, allowing us to generate an image product of 50 centimeter resolution that provides very detailed insights. We have launched more than 100 of our nanosatellites to create a constellation operating like a line scanner of the Earth rotating underneath, capturing images everywhere on Earth almost every day. All of these satellites are operating on a sun-synchronous orbit with a relatively fixed acquisition time. 15 of our SkySat satellites are operating on a sun-synchronous orbit as well, and 6 on a more inclined equatorial orbital plane. For those 6, the acquisition time varies from day to day But the benefit of this orbit is that it allows us to capture individual locations on the Earth multiple times a day. So what is it that drives the value of our customers? Why does high cadence matters and what are the benefits? Even though this example is not showing an agricultural landscape, it is great to highlight why high cadence matters. In April 2020, the Sentinel-2 satellites were not able to capture a single useful image over the area of the Polish National Park Biebrza, while a forest fire was raging on the ground, destroying large areas of valuable forest and marshland. Whereas Planet could provide almost cloud-free images of this region before, during, and after the wildfire event, allowing for a quick assessment of the situation before the fire started and of the damaged area afterwards. This high cadence means higher confidence. Regular data that helps ensure our customers have intelligence to help inform decision-making in key windows over the growing season. And why spatial resolution matters becomes pretty obvious when you're looking at these three images captured by different sensors at different spatial resolution over some fields in Northern Ireland. On the left-hand side, you are seeing an image captured by Sentinel-2 at 10-meter spatial resolution. Spatial variation within the fields can be hardly detected. Landscape features like trees and hedges cannot be identified, and it's almost impossible to see tram lines within the fields. In the 3-meter PlanetScope image, which you have in the middle, in-field growth anomalies become visible, tramlines and even smaller features like trees are starting to be evident. On the right side, you are seeing the sub-meter resolution SkySat imagery of the same location. Here, even individual bushes, trees and hedges can be identified and counted. Containing data from multiple spectra is essential for capturing information about crop vitality that is not visible to the human eye. All PlanetScope data includes data from the near-infrared band, which is vital for agriculture since it allows for detecting detailed information about plant health. Having additional spectral information like the red edge band is valuable because it provides even more sensitivity in detecting changes in crop health. This spectral band sits exactly in the part of the spectrum which is most sensitive to changes in crops' chlorophyll content, and therefore it is beneficial for detecting signs of crop stress earlier. Vegetation indices incorporating the red edge band are often more sensitive to marginal spectral changes of stressed crops and help to overcome the well-known saturation effect of the widely used normalized difference vegetation index. All cropland is captured almost every day with comparable sensors, which empowers large agricultural businesses and service providers to efficiently monitor the fields of their clients in near real time with high resolution imagery everywhere on the globe. This means image processing pipelines and analytic algorithms have to be developed and implemented only once and work all over the world with only minor adaptations necessary. Planet's huge imagery archive enables a better understanding of historical field performance and provides extensive and consistent input data required for training machine learning models. And what is also important for our customers is that we do provide quick and easy access to all the imagery at low cost. We do operate our own satellite constellation, have our own ground stations distributed around the globe to communicate with our satellites and download the captured data as soon as possible. Our complex and scalable processing pipeline is capable of processing lots of terabytes of data every day, allowing us to publish almost all of our imagery in our platform latest within 24 hours, usually much faster. This means you can quickly explore and preview all of our imagery through our web user interface or by using our APIs to pull imagery directly into the tools and workflows you are using. Satellite imagery has been used in agriculture since decades, since it can provide value across the entire agricultural value chain. In the upstream part, it is typically used to better inform field and pasture management decisions and enabling precision farming, but it also provides insights into field productivity and crop damages, supporting financial institutions providing lending and insurance services. And downstream satellite data is often used as one input data source for yield prediction models to better inform price development predictions and trading decisions. Around crop production, satellite imagery is basically beneficial for supporting various crop management decisions and activities throughout the entire crop cycle. Delineating management zones in fields is an essential first step in planning the application of inputs. Vegetation indices calculated from historical imagery can be used to create baselines for an in-field variation of crop productivity, which helps agronomists to set site-specific crop production goals and recommend addressing different parts of the field in appropriate ways. Early in the season, soil brightness maps provide insights about the relative spatial variability of soil properties, mainly associated with the average water holding capacity, soil type, and organic matter content. This information can help to better inform the decision of what to plant, which variety is best suited in which part of the field, and to decide about the appropriate site-specific seeding density. Frequent crop health monitoring across the growing season enables making better informed management decisions in almost real time as conditions change on the ground due to factors like weather, nutrient supply, pests, and diseases. Detecting vegetation growth issues as soon as they occur and combining these insights with on-the-ground data, letting farmers know precisely when and where to act before large-scale yield damage happens. In the past, farmers often spent hours conducting systematic surveys of entire fields to locate and identify problems. Maps generated from up-to-date satellite imagery can quickly and accurately guide farmers to affected areas, making field diagnostics much more efficient. These maps can serve as well as a basis for generating variable rate treatment prescriptions to support in-season crop management activities, such as fertilization and pesticide application, which require site-specific treatment decisions at specific key growth stages. And at the end of the season, knowledge about the crop senescence level of different fields helps to better manage harvest operations. Vegetation indices sensitive to variations in crop senescence provide the ability to map crop drying patterns within fields, helping to guide site-specific determination of kernel moisture content and updating the harvest priorities. Planet's APIs are the best way our customers connect to our catalog of imagery and deliver it at scale to the analysts, agronomists, and farmers who utilize it to make decisions. Our data API is used to discover imagery and build filters to get the imagery that works best for the specific need, including area and time of interest, as well as cloud cover filter. The Orders API is used for custom processing and ordering, providing some raster processing tools like clipping, reprojecting, and co-registration of temporal image stacks. Our newest API is the Subscriptions API, which brings functions of data and Orders API together. It is combining search, processing, and delivery functionality in one single API, making interaction with Planet's catalog easier and faster. With only one API call, it enables the continuous delivery of imagery you need. We will push imagery automatically to your cloud bucket as soon as it becomes available. So to give you a sense of what continuous imagery delivery for agriculture would look like in the Subscription API, in your environment, you'd start with a cloud storage location and the pipeline you've developed to analyze the imagery and to generate your products on top of it. You would then create a subscription, and on our back end, we take your subscription and spin up a catalog monitoring feed to look for newly published items which meet your criteria, and a processing and delivery workflow based on your tools and delivery blocks that you have specified. Then, when a new item is published, which meets your criteria, our catalog monitoring sees it and sends it off to your cloud storage, where it makes the way through your processing pipeline. Yeah, and what's coming next? First, we are adding more spectral bands. We have recently developed a new sensor to be more compatible with public data from Sentinel-2. In the top row, you see the spectral bands of Sentinel-2 satellites. Planet Classic satellites provided 4 bands, as you can see in the second row. Those bands are quite broad and overlapping, resulting in a limited sensitivity to marginal changes in spectral reflectance of crops. As you move down, you see the spectral bands of our new SuperDove sensor. We have tightened our bands to make them more sensitive and aligned with Sentinel-2 and added additional spectral bands. Now we are delivering 5-band satellite imagery to our customers, and by early 2021, the 8-band imagery will be available. With the additional green band combined with yellow and red edge, you will be able to do more advanced spectral analysis and gain more detailed insights into plant health. A second technical update we are very excited about that is coming soon is our Planet Fusion monitoring. Planet has been pioneering a method to enhance, harmonize, intercalibrate, and fuse cross-sensor data streams leveraging rigorously calibrated gold standard satellites such as Sentinel-2, Landsat, and MODIS. Planet is building the next generation analysis-ready sensor fusion dataset that features the radiometric and spectral characteristics of public datasets, such as Sentinel-2, in synergy with the superior spatial and temporal resolution of the Planet Dove satellites. This fusion monitoring will help to unlock the full potential of Planet's daily dataset and is basically aiming at two different aspects. We are improving the interoperability of different sensors within the constellation by harmonizing the radiometry of individual satellites through cross-calibration with perfect calibrated datasets. And we are producing a complete gap-free view of the whole growing season by means of machine learning-based prediction models. This short video visualizes on the right side the challenges working with multi-sensor data streams. This is highlighting spatial and temporal inconsistencies due to cloud coverage, gaps, and the fact of having sensors with different spectral response and band characteristics. On the left side, you see how it looks after fusion processing to create a clean, radiometrically harmonized surface reflectance data feed. Fusion is built to provide more than just a complete picture of the land over the growing season. Because it provides robust surface reflectance data, it is capable of producing data on crop phenology that is remarkably accurate to readings from sensors located on the ground. Due to its temporal radiometric consistency and cadence, Planet Fusion data can be used to accurately locate specific key dates across the life cycle of a plant for making timely decisions about pest management, fertilization, and irrigation, and to supply estimates of the total yield of a crop. We at Planet think that this product will be a game changer for imagery-based agricultural analytics. With Planet Fusion, we are going to provide an analysis-ready data stream which removes the burden of cumbersome pre-processing and reduces friction of data integration from our customers. The Planet Fusion monitoring product will be ready in early 2021. Stay tuned for more updated information coming soon. With this, we have reached the end of this webinar. Thank you for your attention. In case you are interested in learning more about Planet Fusion monitoring, or how to get access to Planet imagery, just reach out to us. Thank you.